Today it is very important question of parallel line, and thereafter I will go the last chapter of three dimensions of class 12, the plane. Question is here, find the vector equation of the line passing through the point 4 minus 1 5 and parallel to the line vector r is equal to 5 plus j plus 3k plus lambda 2I minus 2j plus k. Also find the distance between these lines. Here we have to find the equation of line passing through this point 4 minus 1 5 and parallel to the line, and we have to find the distance between these two parallel lines. Solution. The given line is vector r is equal to 5 plus j plus 3k plus lambda 2I minus 2j plus k. The given line is vector r is equal to 5 plus j plus 3k plus lambda 2I minus 2j plus k, equation 1. The required line, the line passing through point 4 minus 1 5 and parallel to this line, given line, is required line. The required line is vector r is equal to 4I minus j plus 5k plus mu 2I minus 2j plus k. Vector r is equal to 4I minus j plus 5k plus mu 2I minus 2j plus k, equation 2. These lines are line 1 and 2. These lines are of the form r is equal to vector vector r1 plus lambda vector u, and vector r is equal to vector r2 plus mu vector u. Here r1 is equal to 5 plus j plus 3k, r1 is equal to 5 plus j plus 3k, r2 is equal to 4I minus j plus 5k, r2 is equal to 4I minus j plus 5k, and u is equal to 2I minus 2j plus k, 2I minus 2j plus k. Vector r1 is equal to 5 plus j plus 3k, vector r2 is equal to 4I minus j plus 5k, and vector u is equal to 2I minus 2j plus k. Therefore, vector r2 minus vector r1 is equal to vector r2 4I minus j plus 5k, 4I minus j plus 5k minus vector r1 5 plus j plus 3k, 5 plus j plus 3k, 4I minus 5 to minus I, minus j to minus 2j, 5k minus 3k plus 2k. Vector r2 minus vector r1 is equal to minus I minus 2j plus 2k. And mod vector u is equal to mod of vector u is equal to a square root coefficient 2 minus 2 1, so 2 square plus minus 2 square plus 1 square, 2 square plus minus 2 square plus 1 square, square root 4 plus 4 plus 1, square root 9, that is equal to 3. And here, vector u cross vector r2 minus vector r1 is equal to vector u cross vector r2 minus vector r1, vector r2 minus r1. I, j, k, it is in determinant form. The determinant I, j, k, u, the 2i, 2 minus 2j plus k, taking coefficients, the 2 minus 2, 1, 2 minus 2, 1, and r2 minus r1 minus I minus 2j plus 2k taking coefficients, the minus 1 minus 2, 2, minus 1 minus 2, 2. Determinant I, j, k, 2 minus 2, 1, minus 1 minus 2, 2. It is equal to, solving it, it is equal to I into minus 2 into 2, the 4, minus 2 into 1, the minus 2. The minus 4 minus 2, the minus 4 plus 2 into I, plus j into 2 into 2, the 4, minus 1 into 1, the minus 1. The 4 minus 1, the 4 plus 1 j, plus k into 2 into minus 2, the minus 4, minus 1 into minus 2, the 2, the minus 4 minus 2, minus 4 minus 2 k, that is equal to minus 4 plus 2, the minus 2i, 4 plus 1, the 5j, minus 4 minus 2, the minus 6k, vector u cross vector r2 minus vector r1 is equal to minus 2i plus 5j minus 6k. Therefore, mod of vector u cross vector r2 minus vector r1 is equal to mod of vector u cross vector r2 minus vector r1 is equal to square root coefficients minus 2, 5, minus 6, the minus 2 square plus 5 square plus minus 6 square, that is equal to minus 2 square 4, 5 square 25, minus 6 square 36, so 4 plus 25 plus 36, 65 square root 65. Mod vector u cross r vector r2 minus vector r1 is equal to square root 65. Hence, distance between the given parallel lines 1 and 2 is distance between the given parallel lines 1 and 2. Parallel line 1 and parallel line 2, distance between these two parallel lines is denoted by d, then d is equal to mod vector u cross vector r2 minus vector r1 upon mod vector u. Putting value here, value of mod vector u cross vector r2 minus vector r1, that is equal to square root 65, and mod vector u, that is equal to 3. So hence distance between the parallel lines 1 and 2 is square root 65 by 3 units. Thank you and have a nice day.